In the previous section, we explored the configuration and administration of vSphere 6.5, high availability, and fault tolerance. In this section, we will look at configuring and administering vSphere 6.5 virtual machines. In this section, we will take a look at vSphere 6.5 virtual machine essentials. There are some essential topics in this area, which we are going to take a look at. We are going to cover vSphere 6.5 virtual machine essentials. In this video, specifically, we will be taking a look at using content libraries for VM management. We will look at vSphere vApp, UEFI secure boot, and VM power setting management for virtual machines, because these are areas that in 6.5 have been enhanced and are actually very viable for large data center applications. We will begin by briefly talking about content libraries for virtual machine management. We have a separate section on content libraries later on in this course. Basically, the content library is a container for virtual machine templates, for virtual app templates, which we are also going to cover in this video, and for other ISO files, for example. It can be shared across vCenters and obviously gives you consistency across the actual template or the file, so that you could store your ISO file in one specific place and in a content library, and then you can publish from that library to other libraries. So there's a publish and subscribe feature, which we'll talk about later on in a different video, and you can have a local library which can then publish to a subscribed library. vSphere vApps have been around for a long time, and it is a very important part of vSphere data center environment, I think, because it allows you to package and manage interlinked VMs and applications as one unit in a OVF format, so you don't have to deal with like 25 different applications all and wondering when you might have missed one or the other. In terms of management operations, you can apply those policies. For example, the vSphere policies, you can apply them to a vApp and they would apply to all VMs in the container, which makes a lot of sense. The virtual app obviously can have components that can be distributed across hosts. You can specify a network profile for a vApp, which is basically a pool of IPv4, IPv6 addresses, and vCenter assigns those addresses from the pool to these multiple interlinked VMs and applications within the vApp when a vApp actually starts up. And to make a note of the power operations for vApps, when you apply power operations to vApps, they apply to all the virtual machines within that vApp. So vApp is a very, very useful facility, and there are many distributed applications that are packaged in this manner. UEFI secure boot has become extremely important in this security conscious age. How do you ensure that your boot of the operating system has been booted from trusted files? And basically it's a security standard that ensures that only trusted files are booted from. So each piece of boot software is signed. So the bootloader is signed, the kernel, the device drivers, and any part of boot software are all signed, and they are verified. So the VM default profile includes certificates to verify the boots. So if you're booting Windows, there is a Microsoft certificate that is used to verify that the software that is actually booting is signed by Microsoft. There is another Microsoft certificate within the virtual machine default profile, which is used for third-party code. So for device drivers, for example, in Windows, that certificate is used to verify that those device drivers are actually signed and approved by Microsoft. And of course, if you boot ESXi in a virtual machine, there is also a VMware certificate to ensure EXI that is booting from trusted VMware files. And to do all this, you basically need your host to support the EFI firmware. All modern hosts basically support EFI. You need virtual machine hardware version 13 or later, and you need an operating system that supports UEFI secure boot, and again, all modern operating systems would actually do that. This is a tremendously necessary feature, and I encourage you to learn more about it. We will now look at power management options for virtual machines. I'm sure you're all familiar with power management options for the ESXi hosts, but this option allows a virtual machine to stay powered on or be suspended if the guest operating system goes on standby. It's not available on every operating system, and the Wake on LAN supports Windows OS and must be supported obviously by the NIC card. The Wake on LAN feature will not resume suspended, hibernated, or powered off VMs. So again, this is a useful feature to have in order to conserve resources in your cluster. It's something for you to consider.